Hi everyone, my name is Juan Pablo. Welcome back again to a new YouTube video, and in this time we will talk about a very interesting feature, and actually I think it's a topic that concerns to all the companies, either if it's an enterprise company, a service provider, or a small network, which is security, right? Security, as we know, is a big concern across every type of network infrastructure and company, and it applies to everywhere, right? To every single technical topic or in our case, for example, to routing protocols, okay? And that's actually what we want to look into this video. We will look into how security eventually has been evolved for authenticating routing protocols. As we historically know, routing protocols, of course, send control packets across the network, right? If we have two devices here that are establishing OSPF sessions or BGP sessions, normally we want to protect those control plane packets that are needed for establishing those adjacency because we want to have some type of privacy confidentiality across the authentication and avoid someone, of course, in the middle to inspect that packet and get to know what is the information that we have over there, okay? So for a long time ago, and even recently, and even in today's of some in some networks, the common method of authentication has been MD5. Okay, MD5 is a hashing algorithm that basically have an input value. It uses hashing functions and produce an output value. This has been normally the method that we have been all learned from time and years ago to authenticate BGP, OSPF, ISIS, LDP even sessions, right? We have been using MD5 for authenticate our control plane protocols. And this is historically for many years back. Recently, and well, actually a few years back and recently as well, there are many posts of how MD5 is really not secure anymore. It has been a lot of vulnerabilities being catched on MD5 as well. And of course, when the packet going over the network, and when we have, for example, two devices sending control packets and they are authenticated by MD5, then we are in risk of that someone in the middle can intercept those packets, and there is not that protection of integrity of the packet when it's sent across two devices and across the network, right? When someone intercepts the packet, can figure out with some hashing functions and mechanisms what actually is the password and authentication, and can decrypt the packet and of course get to know information going over the control protocols, okay? So there has been many articles highlighting those vulnerabilities, and MD5 doesn't really, as I said, provide the integrity, okay, to ensure that nothing will happen on the packet when it's transported across the devices. And here is where it comes an enhancement to protect that integrity, and this is a very, very important word, because here is where we have the cryptographic algorithms, like for example CMAC, okay, that is a cryptographic message authentication coder, okay. What cryptographic ensure when we enable that in many protocols, like we have been seeing that in IPsec tunnels, in TLS sessions, for example, cryptographic algorithms are very popular in that. MACsec as well is a feature for service provider that also use cryptographic algorithms. It ensures one thing, and is basically what we are missing with MD5, integrity of the packet end to end, okay? So it generates a strong message authentication coders that basically is inserted into every type of control packet that is being sent across the devices, okay? So it ensures the integrity of the session and is much more secure and solid than MD5. And actually is what companies now are trying to move or enhance the security in the network, moving to CMAC protocols, okay? And mapping into that, CMAC, of course, is the behind-the-scenes protocol of TCP/IO. As many of us has known, TCP/IO is essentially is another way that we can authenticate control packets in BGP, but the protocol doing the wall authentication and cryptographic behind TCP/IO is essentially CMAC, because of this fact for enhancing the integrity across devices that are being establishing sessions, iBGP sessions or eBGP sessions, okay? So of course, CMAC is not limited only to BGP. There are options that you can configure CMAC for ISIS as well, for OSPF as well. I think that even for LDP as well, you can insert CMAC. And this is the protocol to go for security mechanism of your control plane packets for your routing protocols. Okay, so given that introduction, we will show you in this video how you can configure TCP/IO in the routers in BGP. Okay, that's the protocol that we will see today. So for the network, we have ASR9K1, we have ASR9K3. They, as you can see in the image, which is actually very colorful and graphic, we have an iBGP session across them. This is our common network that we have been using for the previous videos. So we have an iBGP sessions, and our goal will be to enable TCP/IO across that session. Okay, I will show you what parameters you need for enabling this protocol, and what also CLIs and commands you need for that, and as of course how to verify as well. What commands we can use for verify that the session is actually authenticated by TCP/IO. Okay, so this is my network. I have XR in all the network. Is a XR9000 that I have been using across the videos. The version is 24.3.2. Okay, and let's do it. We will jump now into ASR9K1. And the first thing we need to do is basically to configure a key chain. Okay, we will configure a key chain that is called TCP/IO, for example. We will configure key ID that it will be 1. The key string will be Cisco and Cisco. And here is where we need to configure our cryptographic algorithm. Okay, and here we have many options. CMAC is one of those options, for example, that we were talking in the very beginning of the video, right? But we can configure other ones as well. Another option that we have available here, HMAC with SHA, 196, 20, 12, 256. There are many options that we can actually configure over here. I will just configure with HMAC with 96, just for you to see how is the configuration with another cryptographic algorithm. Okay, so then here, once we have enabled that, we need to also settle other parameters that I was just skipping, that basically is the accept and send lifetime. Okay, so here we need to put accept lifetime 000, 000. In my case, I will put my May 20 with year 2026 infinite, and the same for sending lifetime, which will be exactly the same date. Why this is important? Because this defines our timelines for sending our keys towards our network, our neighbor, sorry. Okay, so it's important that we define the sending lifetime and accept lifetime as well. As you can see, this key chain is actually very similar as you configure for authentication for routing protocols like ISIS, OSPF, or HRP. In BGP as well, it is similar. So there is nothing weird or different, let's say, particularly to TCP/IO in BGP for this part. Okay, so this is the part number 1 that we need to configure the key chain TCP/IO, and the part number 2 that we need to deep dive more into the TCP/IO proper configuration is this one, that we need to go of TCP/IO, and here we need to insert the key chain. Okay, key chain, which will be TCP/IO, the one that we just created before. Okay, and why the configuration is under TCP/IO? Well, because TCP, of course, is the protocol that allows us to establish the BGP sessions and to send the updates and different type of message in BGP, right? So TCP is the protocol that we need to authenticate with cryptographic algorithms. Okay, so that's why all the configurations goes under TCP/IO. One thing is that that I missed to mention probably is that this key chain, of course, has the cryptographic algorithm, and this is the only difference, because again, this gives us the integrity part that MD5, for example, was not giving us in the past, right? So that's why that particular cryptographic algorithm is needed for cover that integrity part. Okay, so let's take now the second part of the configuration, which is TCP/IO. We attach the key chain, and here we need to define some settles of IDs, which will be the sending ID and the receive ID. Okay, these values will be used for calculating the message authentication coder in the negotiation between the two devices, right? At the end, the string that will be generated between both devices that will authenticate those values that we configure here, the send ID and the receive ID, are part of the creation of that strong CMAC or MAC message authentication coder between both devices. Okay, so these values has to be the same both in both devices. In our case, in ASR9K1 and ASR9K3, it can be different and still the session can be established, but it's not the recommended one. Okay, so saying that, this is the configuration basic that we need to have, and of course the last part missing is going to router 3 and attach the TCP AO and tell router 1 in our case that for the session to router 3 we will configure and use TCP AO as a mechanism for authentication. And for that we need to type TCP AO first, then the name that we define it in the keychain for TCP AO, and here we can add include TCP options, enable. So these last two commands will basically give us the option to authenticate the TCP options as well with our cryptographic algorithm. Okay, as you know, TCP has many other options available, like MSS, Windows size, for example. So with this command, we are allowing the device to also authenticate with the cryptographic algorithm the TCP options. Okay, and here we have also the accept AO mismatch connection. So this basically will allow us to accept the authentication between the two devices if the send ID and receive ID are different. Okay, so for now we will just configure this here, and this is pretty much all the configuration that we need in the device. Okay, so we'll just configure and commit this information here. I cannot, well, I need to do the same configuration in P3, but we have normally a mistake always with the password, is that we just copy paste whatever is needed. So in my case, for example, all this part it will be the same in ASR9K3, and I can just go and copy paste. But the problem is that the password here in the keychain is different, right? So really be careful what you copy and paste in the other device, because that mismatch of password, just with the simple fact of copy paste, can cause you a lot of headache for troubleshooting. Okay, so I will just copy this part that is exactly similar. So the key string, of course, is Cisco, so this will be similar in the other side. And here we need to, of course, set the same cryptographic algorithm and the send and lifetime that was missing previously. Okay, so now I have the same configuration in both devices with the same password in the keychain. Send and lifetime is the same, and now I just need to go to router BGP, neighbor 1101, and here put AO TCP AO, include options, enable. Here is the log basically that the authentication is not enabled in this device, and the session basically is having problems with authentication. After I type this command, our session should come up back again, and it shouldn't be a problem for the authentication in TCP AO. I think that the session didn't go out because BGP has the hold time of 80 seconds, sorry. So even that we were getting logs for mismatch authentication, BGP didn't fell down or went down in the session. Okay, so now we have both devices configured with TCP AO with the cryptographic algorithm HMAC and SHA. How we can verify? There is no a command essentially that we can do in BGP, because all the configuration is at the TCP level. So if we want to make sure that we have the session covered with TCP AO, we need to check the TCP session already built. So for example, in our case, I am now in ASR9K3. So I need to take a look what session is to ASR9K1. So it's this one. I copy the PCV, and here I need to type show TCP detail, PCV, location, and here the RP 0, CPU 0. I have option here to type the line card, but I will not do it because TCP AO works in the CPU of the box, which is the RSP. Okay, and here I just type begin authentication. Okay, and here I can see many parameters which are actually already built for the session. So for example, it's the peer 1111. I have BGP as well. We have the keychain name. We have the current key ID, the receive key ID, and the traffic keys as well are being generated. Okay, So this is basically the information that will give us sense that the session is basically up and running. Perfect, and that was the video of today. We saw TCP/AO authentication, how we can configure, how we can verify in BGP. As you know, security is a big concern for every type of aspect, for medium and small networks, for service provider networks, for core infrastructure it impacts the most, and of course for the routing protocols as well. So every time any mechanism that helps us to enhance the security part and avoid vulnerabilities and leaks, this is the one that obviously we would like to prefer in our core network. So I hope this video has been informative for you, that you have enjoyed and learned something, and see you in the next one. Thank you.